Now coming to the application of the Nernst equation, which I told you the last class. Nernst equation can be used to calculate the concentration of the unknown electrode. That is the last class I said you. What is the Nernst equation? It was E cell is equal to E naught cell minus 0.0591 by n log concentration of product by concentration of reactant. I said you this. Now product and reactant will contain what? Electrodes, definitely. So if you do not know the concentration of either of the electrode in the product or the reactant, you can find it out by using the Nernst equation. This is the first application. Suppose you know E cell, you know E naught cell, you know N, but suppose you do not know the concentration of product, you can find it out. Or you do not know the concentration of reactant, you can find it out. Clear? This is the first application. Clear? Next is, we can also find the pH. Alright, the value of pH. You read it, what is pH? Minus log of H plus ion concentration. In class 11 you studied the pH. So you can calculate the pH from the Nernst equation. Now how? Now if you are going to calculate the pH, definitely one of the electrode has to be hydrogen electrode. Definitely. Otherwise how will you find minus log of H plus ion concentration? Suppose if H plus ion is not there. Suppose one is zinc, another is copper, and he will ask you to find the pH. It is absurd or not? Because there is no hydrogen, I am asking to find the pH. So if I am asking to find the pH means definitely one of the electrode or what you can say, there must be an hydrogen ion concentration present in it. Then only you will be able to find it out. Otherwise how do you find it out? Okay, fine. See here. Now here it is what I am going to do. That is nothing but H plus E minus, because H plus will gain an electron to form half H2, which is nothing but a gas, and this is aqueous. Definitely you know that. Ions means it has to be in the aqueous state. Fine. So this is the reactant and this is your product. Done. So same E cell. So instead of E cell, what should I write? I have to write it in reduction potential. E half H2 slash H plus. I should write it this way, isn't it? Then that is nothing but E naught, that is half H2 slash H plus, isn't it? I have to write it this way, minus 0.0591 by n log product is what? That is concentration of hydrogen to the power half by concentration of H plus ion. This is E cell. Instead of cell it is reduction potential I have written it. E naught cell, instead of E naught cell I have written reduction potential because about this particular electrode. Minus 0.0591 by n, the value of n will be how much? It is 1, you can see here, log concentration of H2 to the power half. Now H2 is what? H2 is a gas, you can see there. So what will be the gas? In case of SHE, what I have said you? 1 atm. The partial pressure of hydrogen gas is 1 atm. So it will be 1. Here I am writing it as 1. So hence what you will be getting it as, I am writing E and I am writing E naught minus 0.0591 by n, n is 1, you know that I have said you, log, what is that? 1 by H plus ion concentration, isn't it? Now here, listen here, what is the value of E naught? In case of SHE, what is its value? 0. E naught, this particular value is what? 0. This is 0, this particular one is, isn't it? SHE, what is the value? Standard hydrogen electrode, what is the value of EMF? It is nothing but 0. So 0 it is done. Okay, should I write 0? No. So now here, so what you find is that here it is now minus 0.0591. I can write this one as this one, log 1 by H plus. Log 1 by H plus means what? Log H plus to the power minus 1. Maths, log H plus to the power minus 1. So you have read it, log A to the power B is what? B log A, you have studied. So log H plus ion concentration to the power minus 1, it is nothing but what? Minus log H plus ion concentration. So what I can write this one as? Into minus log H plus ion concentration. Have you understood or not? Log 1 by H plus will be how much? Log H plus to the power minus 1, just now I said log H plus to the power minus 1 is how much? Minus log, I don't have the place here, that is minus log H plus ion concentration, because log A to the power B is V log A, you have studied in maths. So I can write this one, log 1 by H plus, I can write in this one. What is this? It is nothing but what? That is pH. So minus 0.0591 by 0.0591 instead of log minus log H plus, I can write it as pH. So you got it. You can say that is E half H2 slash H plus, or if it is a cell, let us say this is a cell. So E cell is equal to this particular value, you got it. Minus 0.0591 by 0.0591 into pH. So you can calculate pH from here. If you know this value, you divide it, you will get the value of pH. Got it now? In this way, pH can be calculated by using Nernst equation. You can also calculate the equilibrium constant by using the Nernst equation. You can calculate the equilibrium constant by using Nernst equation. How can you do so? Now see, equilibrium constant means, let us write an equilibrium reaction. XA plus YB gives ZC plus WD. This is an equilibrium reaction. So that is nothing but, in case of equilibrium reaction, what you find is that is Kc is nothing but, that is concentration of C to the power Z, D to the power W by A to the power X and B to the power Y. You know that? Concentration of product by reactant? Fine. Now, this is product by reactant, mind it. So, E cell is equal to, same formula, E naught cell minus 0.0591 by N log concentration of product by reactant. So, I can write this particular one, concentration of product by reactant. I can write this, or I can write by concentration product by reactant, I can write this log Kc directly. I can write concentration product by reactant. Have you understood or not? That is, what is it? Log concentration product by reactant. So what is product by reactant? It's nothing but Kc. I can write it. So when I am writing Kc, then the value of E cell will be 0. Why? Because you have seen it. I have told you earlier when I am teaching you the electrochemical series that if E cell is positive, the cell reaction is feasible. If E cell is negative, cell reaction is not feasible. If E cell is 0, the cell is in equilibrium. So here the cell is in equilibrium. Alright? So it is 0. So hence, if I bring this one, it becomes minus. So minus minus will get cancelled. E naught cell is equal to 0.0591 by N log Kc. So if Kc is not known, we can calculate by putting the value of N and E naught cell. That's it. In this way, you can calculate the equilibrium constant. The next one we will see, that is, we are going to see, that is Gibbs free energy. Now Gibbs free energy you studied in class 11 in thermodynamics. Gibbs free energy is delta G. Delta G is minus NF E cell. You know it? Minus NF E cell. And standard Gibbs free energy delta G naught is minus NF E naught cell. If it is standard, this also has to be standard. E naught cell. Now we will simplify this one. Alright. Now that is minus NF E naught cell. So what is E naught cell? Just now I said you E naught cell. That is, I want to find out a relationship. Let me tell you. I want to find a relationship between Gibbs free energy and Kc, equilibrium constant. Okay. For that reason I am doing it. Clear? Otherwise you got it. This is from here, whatever is unknown you can find it out. Clear? Now, E naught cell, just now I said you, is nothing but is equal to 0.0591 by N, that is log Kc. You put the value? Alright, or you can write that is E naught cell is equal to, that is nothing but 2.303 RT by NF log Kc. You can write down this also. 2.303 RT by NF log Kc. Now you put it here. Delta G naught is equal to minus NF into 2.303 RT by NF log Kc. See, instead of E naught cell I am putting the value. Instead of this E naught cell I have put this value. Okay, NF cancels, and what you get it? Minus 2.303 RT log Kc. So this is the relationship between equilibrium constant and Gibbs free energy. We can find it out. The equilibrium constant and Gibbs free energy. In this way we can get it. The relationship. This is another one. We can get it. So now after this, this is what you can say. This all relationships. So this all relationships, where it will be used? It will be used to do the numericals. To find the pH, to find the equilibrium constant, or to find the standard Gibbs free energy, or suppose Gibbs free energy is given and equilibrium constant is asked in this way, or suppose concentration is asked to calculate, unknown concentration is being asked to calculate. So all these things will be asked there. Alright? Okay, thank you very much.